Okay, problem number 3 from the quiz. There were 2 different molecules, but the procedure is identical. We have a chemical compound, C3H6S2, and the question asks, what is the mass percentage of sulfur in this compound? The percentage is going to be the mass of the sulfur divided by the total mass. So before we can dive in to that part of the problem, first thing we need to know, what's the total mass of the compound? So we have 3 carbons. So we're going to multiply by molar masses. So we have 3 carbons times 12.001. That gives me 36.0, I think that's 0.033 grams per mole. Hydrogen. We have 6 hydrogens in this chemical formula. So hydrogen weighs 1.008 grams per mole times 6. So 6.048 grams per mole. And sulfur. We've got 2 sulfurs, which is going to be 2 times 32.064 grams per mole. The periodic table I gave you gives more significant figures for hydrogen. You're more than welcome to use them, but because I know the fact that carbon, tenths, hundredths, 1,000th, I know that that's the highest accuracy I'm going to have. There's no point in taking this out to 5 or 7 more decimal places or whatever. So just a note on significant figures, that if you had a better periodic table, then we could get this number to a higher degree of accuracy, but this is going to be fine for this particular problem. We have the mass of each element, and it is worth taking the time to write them out separately, and you'll see why in a second. So our total mass which is really just the molar mass, right? I mean, regardless of what we're calculating here, percentage is going to be the item we're interested in divided by the total. In this case, it's going to be molar mass of what we're interested in, sulfur, divided by the molar mass of the total. But we have to take into account that there are 2 sulfurs. So the total mass is 106. 0.209 grams per mole. That's our sulfur that we've already got written out nicely. So our percentage is just going to be 64.128 grams per mole divided by 106.209 grams per mole. Since it's a percentage, we have to multiply by 100. Notice from significant figures, I tried to line up the decimal points. If I take a step backwards. So each one of these, 10th, 100th, 1000th, each one of these goes out to 1,000th. So that's how I can get away with 106.209. 5 significant figures, 6 significant figures. So my final answer will be to 5 significant figures. And 60.38% sulfur. As I look at my notes, I rounded, which is a bad thing. So I actually should knock myself off a point because I actually should have one more decimal place. I don't remember what it is, if it was a 0, but I'm too lazy to get my calculator. So it should actually be 60.38 something else here. But that's just a sig fig type of thing. 60%, 60.38% of sulfur. So when I edit this video, I'll throw in what that last significant figure is. I noticed that some of the problems you guys were having was just where do you start with this? And this is why you need to be very comfortable with molar masses, those type of conversions, because the only way we can calculate relative percentages when we're just given the formula is to use the respective molar masses of each compound. If I would have written this problem where I told you we have 5 grams of carbon and 20 grams of hydrogen and 95 grams of sulfur, that's a completely different story. Then you could use those values. But all I gave you was the chemical formula and a periodic table. So the relative masses are referring to that. Now, another thing I just glossed over, grams per mole divided by grams per mole. Cancel. So that is why we don't have a unit of measure for a percentage, because the units automatically cancel themselves out. So C3H6S2 is about 60.38% by mass sulfur. And we could figure out the percent by mass of carbon and hydrogen if we wanted to do another set of calculations.